In this concept, we're going to talk about reflections. A reflection is a type of transformation that flips a figure over a line, called the line of reflection. Okay? A reflection has the following properties. If a point is on the line of reflection, it does not change position, right? So if I give you a line of reflection, let's say the x-axis, right, and I have a point on the x-axis, say the point, 3 and 0, and I say reflect this point on the x-axis, its reflection is still 3 and 0. Okay? The second property of reflections is that a point and its image must be equidistant from the line of reflection. So if I have 2 and 1, the point 2 and 1, and I tell you to reflect it about the x-axis, right? So the distance of this point from the x-axis is 1, right? Because the y-coordinate is 1, so this point is 1 unit away from the x-axis. So to reflect it, we need a point that is also the same distance from the x-axis, right? So its y-coordinate is going to be -1, but the x-coordinate is still going to be the same. So the reflection in this case will be still 2, but -1. Okay? And here, let's look at an example. And again, if we have a line of reflection, so I use the example of the coordinate axes, right, or one of the coordinate axes, the x-axis, but it could be any line, right? It could be a defined line, like an equation of some line, right? X equals 3, x equals -4, or so that's a vertical line, or it could be a horizontal line. It could be whatever. It has to be specified at first. So in this case, we have this line of reflection, and we're saying that, okay, we need to reflect this shape, which is essentially a triangle, about this line of reflection. So the triangle is made of 3 vertices, right? So we can reflect the vertices by, again, just upholding the rule of the reflection has to be the same distance from the line of reflection as the original point. So in this case, point A is 3 units away from the line of reflection, so point A prime, the reflected point, has to also be 3 units away from the line of reflection. Point B, same for point B, 3.1 units, 3.1 units. Point C is on the line of reflection, so the reflection is at the same location. Okay, it does not change position. Okay, notice that a reflection is an isometry since the size and shape of the pre-image does not change. So size and shape do not change. Okay, position changes. Here's another example. What are the coordinates of point P 2 and 1 after reflecting it over the line y equals -1? So in this case, we have a predefined line, not one of the coordinate axes. So all we do is just we graph that line, right? So y equals -1 is just this horizontal line right here, crossing the y-axis at -1. And then we plot the point P 2 and 1, and we need to reflect the point about this line. So this point is 1 unit away from the x-axis, but that's not what we care about here, right? We care about the line of reflection. So it is 2 units away from the line of reflection. Keep that in mind, okay? When you have a line of reflection, aside from the coordinate axes, you have to determine the distance to the line of reflection, not to the coordinate axis, or either coordinate axis. Okay? So it's 2 units away from the line, right? Because 1 unit here to x-axis and then another unit here, so 2 units away. So then the reflection also has to be 2 units away, right? So -1, and then 2 units from -1 is -3. So then this would be the reflection of that point about the line y equals -1. Okay? Here's another example. Now we have a figure, so essentially a square, with the following coordinates for its vertices, or corners. And we need to reflect it over the line x equals 4, which is this vertical line right here. So again, we just go ahead and reflect each vertex or each point by itself by keeping in mind that the reflection of each point has to be the same distance from the line of reflection as the original point, but just on the other side. So taking point A is, here's 2 units, width of this leg of the square, and then another 2 units to the line of reflection, so point A is 4 units from the line of reflection. So point A prime has to be 4 units from the line of reflection on the other side. Okay, same for point B, so it's 4 units from the line of reflection, so point B prime is 4 units on the other side. Point C is 2 units from the line of reflection, so C prime is 2 units on the other side, and then same for D. 2 units, 2 units. And then we just, can connect the reflected points to get the reflection square. Okay, and then we can obviously specify the coordinates of the reflection points. So A prime will be at 8 and 1, B prime will be at 8 and 3, C prime will be at 6 and 1, and D prime is at 6 and 3. And again, this is just taking into account all the new coordinates. Okay, and here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so here we have a couple of points, and we need to reflect them over the x-axis. So 3 and -2 is somewhere here. So reflecting it over the x-axis, so it's basically 2 units from the x-axis, so we just reflected 2 units on the other side, which amounts to essentially just flipping the negative sign of the -2, right? So it'll be just 3 and 2, right? -2 and 5, reflecting it over the x-axis, so it's 5 units away from the x-axis, so we go 5 units on the other side. So that essentially amounts to, again, flipping the sign on the y-coordinate. So still -2 for x, but -5 for y. Okay? And the point 0 and 0, which is the origin, and again, since it's on the x-axis, so reflecting it over the x-axis does not entail a change in position. So its reflection remains 0 and 0. Next exercise. Reflect the following figure over the line x equals 3. Draw the image on the coordinate plane. So we have the line x equals 3, and we can just graph it just like this as a reference. This way and this way. There we go. Right? So again, we use the same procedure. So each leg of this square is 2 units, right? So 2 units. And then this is 1 unit, right? So point A is 3 units away from the line of reflection. So the reflection of point A will be here, right? So this is A prime. Point C is 1 unit away, so the reflection of point C will be 1 unit away on the other side. So this is C prime. And the same for D, D prime, and B. right? And then we can write the coordinates for the points. So point A prime will be at 6 and 1. B prime will be at 6 and 3. C prime will be at 4 and 1, and D prime will be at 4 and 3. Okay? This is it for this video. See you in the next video.